We want to talk about density and how integrals can be used to solve density problems. Um, to put up here a typical problem, this is sort of a one-dimensional version of the problem. So let's suppose the density of a 2-meter rod is 1 minus e to the negative x kilograms per meter at a distance x meters from the left end of the rod. So what is the total mass of the rod? Let's just draw a picture of what I mean here. So we have here a rod like that, and this is the left side of the rod. And so let's say that's 0 from the left end, that's 1 from the left end, and that's 2 from the left end, measuring those distances in meters. So the question is, what's the total mass of the rod? It's made of some material that miraculously has a different density depending on how far to the right that material is. So what we want to do is the way you can imagine we approach this problem in calculus is we're going to add up little bits of the rod. So let's ask, if I have that little tiny slice of the rod, how much mass does that have? It's something in me prevents me from saying how much does it weigh, because technically with mass we're not measuring weight, we're measuring mass. So okay, so anyway, the width of this little tiny slice, we all know what little tiny bits of anything are called in calculus. This is in the horizontal direction. It's tiny in the horizontal direction, so we call it dx. Now, how much does it weigh? Well, what we know is that I can tell you, given any particular length of the rod, how much it should weigh. So that's what this number is telling us. It's saying how many kilograms it weighs per meter of its own length. So this is going to be have a mass equal to 1 minus e to the negative x dx. Now, why is that? Well, first of all, let's put in a point here and call that x. So we can say that the mass of one tiny bit of rod equals, I should put in a qualifier here, at distance x from the left. In other words, I'm measuring this amount of distance from the left. This tiny bit of rod is going to equal 1 minus e to the negative x, because that's kilograms per meter, and then that tiny bit of distance is measured in meters. And I think I've made the point before that if you can get the units to come out right, you've usually found the right expression. It's not universally true. It's possible to do it wrong, but it's often a good guide as to how to do it. So if that's the mass of one tiny little bit of rod, what do we do in calculus? We use the integral to add it up. So the integral of 1 minus e to the negative x dx from the lowest possible x value up to the highest possible x value, which goes 0 to 2. And so I'm just going to zip through the algebra. So there we go. That's the mass of the entire rod.